Okay, we just got done multiplying monomials by polynomials. So basically we were just distributing one term throughout the entire polynomial. So now we're going to build on that. We're going to begin with multiplying two binomials at the same time. And this is called the FOIL method in which we use to do this. So let's take a look at what two binomials being multiplied looks like. If you notice, we got two binomials, right? It's a polynomial with two terms. Here's one, here's the other, and the multiplication with the parentheses. So it's the product of two binomials. And how we do this, what this FOIL method means, is we are actually going to distribute one of the polynomials to the other one. And so this FOIL method, it stands for first, outsides, insides, and last. And what that means is we're really distributing the whole time here. Okay? So it's basically just the distributive method. So we're going to take this 2x, and we're going to begin by distributing it to the second term, or the second polynomial. So the first, 2x and the x are the first term in each binomial. That's why we say the first. So we're going to multiply those two first. And then we go to the outsides. Well, 2x and the -5 are the outside terms. So those are the next two that we multiply. Then we go to the insides, which would be the 3 times the x, because those are the two inside terms. And finally, we do the last, which is the 3 times the -5. So it's that FOIL means, but it only works with two binomials. I like to just think of it as just distributing, just like what we've done before. So let's actually take a look at how we attack this problem here. So same type of problem. My way of thinking, instead of thinking the FOIL and going first, outside, inside, last, I just take my first binomial here, and I got to understand that I need to distribute this 2x, and I also need to distribute the 3. And I just take each one at a time. So I distribute the 2x. So I got to take 2x times the x in the other binomial. So 2x times an x would be 2x squared, right? X times x I can write as x squared. Then I go ahead and take 2x times that -5. Don't forget to do the -5. And really I'm just multiplying 2 times -5, which is -10. And I still have my x left over. So I did the first and the outside so far. Then I also do the insides and the last. So I'm done distributing the 2x. Now I'm going to go ahead and distribute the 3. So I take 3 times that first term in the second binomial, which gives me a positive 3x. And then I take 3 times that -5 again to give me a -15. And before it's simplified, I got to see if I can combine any like terms. And if you notice, I have two terms of x. I have a -10x, and I have a positive 3x to simplify into a -7x. So I bring everything else down. That doesn't simplify. So I still have my 2x squared, my -10x, and positive 3x combined for a -7x. And we still have our -15 left over. And that would give us our simplified expression, which is actually a quadratic, which we'll get into next chapter. Okay, so you can think about the FOIL method if you have two binomials. Otherwise, just think of it as distributing, right? And you got to distribute each term. That's kind of the way to go. Because if you look at this next example here, it's not just two binomials, so you can't just think of FOIL, right? There's not just outsides, insides, and last and first. There's a few more to do with it. So this is where you got to think, I got to distribute each term one at a time. Right, so let's go ahead. Let's start off. We're going to distribute that 3a, and right, just do one term at a time. So I'm going to take 3a times a squared. Well, 3 and then a times an a squared, that's really 3a's. So a to the third, right? A times a times a. And then I go to 3a times -12a. So we multiply our coefficients. 3 times -12 for a -36. And an a times an a, I can simplify into a squared. And then lastly, 3a times 1, which is just 3a. So we're done distributing the 3a. Go to the 4, and we got to distribute the 4. So 4 times a squared just gives you a positive 4a squared. And then 4 times -12a. Well, it's your 4 times -12 for -48. Then you have your a left over. And lastly, 4 times 1 for a positive 4. And just like the last problem, we got to simplify it all the way. So see if you have any like terms. I'll just go term by term. So I look at my 3a cubed. I don't have any other a cubed, so I bring that down. Done with that one. Now we got an a squared. Any more a squareds? Yes, we do. So we got a negative 36a squared and a positive 4a squared to combine for a negative 32a squared. And we also have two terms of a 3a and a negative 48a to combine into a negative 45a. Right, just combine their coefficients. And lastly, we have our positive 4 left over. And now we're simplifying. Okay, so pretty much just the distribution property, but you got to make sure that you do each and every term basically throughout there. Last thing, let's use this in geometry here too as well. It asks us to write an expression for the area of the triangle. Well, before we can do that, we got to remember what area of a triangle is. And if you remember, it's basically half a rectangle. So instead of using length and width, we use base and heights for triangles. And so it's 1/2 base times height. So 1/2 times the base times the height. Some other people will think of it as base times the height and then divide by 2. It's the same thing, right? Multiplying by 1/2 and dividing by 2 is the exact same thing. Well, we just want to plug in the information that we have. So to find the area, I'm going to use my first equation. I got 1/2 times the base. Well, the base is 6x plus 4. And since it's a binomial, or just any polynomial, you should put it in parentheses. So I'm going to put that 6x plus 4 in parentheses. And then I want to take it times the height as well, which is x minus 7. So I'm going to put that in parentheses as well. And if you notice, we have two binomials, right? A product of two binomials. So I can use the FOIL method, or like we described before, just distribute each term. So let's go ahead and do that. I'm going to just bring my 1/2 down here first, because I'm not using that yet. And I'm going to distribute the 6x to that second binomial. And I'll keep this in parentheses. So 6x times x for a 6x squared. 6x times negative 7 gives us a negative 42x. And then we also distribute the 4, so 4 times x, positive 4x, and 4 times negative 7 for a negative 28. Oh, I forgot my x down. Okay, and then let's simplify that. So I still have my 1/2 out front here. Bring my 6x squared down, and a negative 42x, and a positive 4x for a negative 38x, and a minus 28. So I'm saying my area equals that so far. Well, I can actually, if you notice, I have that 1/2 out front. I can distribute that 1/2. Okay, I can go ahead and I can distribute that 1/2 just like we did the other day, multiplying a monomial by a polynomial. So basically just cut everything in half, right? So my final answer is going to be 3x squared minus 19x minus 14. And there's really no units, so I could just say units squared, right? Because we're talking area. And that would be my final expression. So just applying algebra to some geometry. You're still doing the same thing, just follow the rules that we learned. And like I said, it's pretty much just the distribution property throughout this whole lesson here. Okay, that's all I got.